Welcome back. We made it to the last video in lesson 3. Trust me when I say I'm as excited about this as you are. For 5 minutes of videos, it takes me 20 minutes of my life. Probably the same for you all. Let's get over with this pain. In this video, we're going to confirm that solving equations using a graphical technique indeed produces the same solutions as when we do it algebraically. This video will be most helpful for those of you that have finished lesson 3 video 15 already, though really anybody could watch this. Let's jump right into it. Suppose we come across this problem. Complete all 5 steps of the graphical technique. I don't know who wrote this problem, but they should have wrote the word "the" in there. Complete all 5 steps of the graphical techniques to solve the equation x squared minus 4x equal 12. All right, we take a deep breath. Before we do any other work, we ask ourselves the exact same question as always. Is there an equals sign? We see right there is an equal sign, which means we're going to solve this equation. We also see there's a square right there. Square in español decimos cuadro o cuadrado, depende. This is a quadratic equation. We also know that we want to use all 5 steps of the graphical technique, but maybe we need a reminder on what those are. To find the solutions of an algebraic equation using a graphical technique, we're going to complete the following 5 steps. Step 1, identify and graph the left-hand side of the equal sign. Step 2, identify the function on the right-hand side of the equal sign and graph this function on the same axis as step 1. Before we go on and review the next 3 steps, let's complete those for our specific problem. All right, we're back at this problem. I like to specifically identify what I call the left-hand side and the right-hand side of my equation. In this case, we'll say that the function on the left-hand side we'll call y1, and we see that's going to be x squared minus 4x. And to be honest with you, I kind of like thinking about this one in blue. It's because I was gifted one of those fancy color calculators, and y1 is always in blue. On the right-hand side, the function we'll call y2, and in this case, it's 12. Before I go run and get my calculator, I'm going to go ahead and say, do you notice that this 12 is constant no matter what? In other words, if x is negative 4, guess what the value is? 12. If x is negative 3, 12. Negative 2, 12. 12. Oh my God, this is one of the easiest functions ever. Hey, all I gotta say to this, whoever wrote this problem, is just keep throwing functions like that at me, right? Because I can do that all day. This side is a little harder, right? This side actually takes some work. We have 2 ways to do this. We could sufrir, we could like really feel pain, I guess like a good Christian. But the better way, I think, to do it is to get our calculator out. I know my ahijado always says that his teacher doesn't allow him to use calculators, and to be honest with you, I want to talk with those teachers. Here we go. Let's go ahead and type in x squared minus 4x for y1, and y2 we'll type in 12. Remember, we want to fill out this table. To fill out the table, we're going to click the table button. Table is written in blue, so I hit the second. There's that little up arrow that represents the idea that I'm going to hit the blue ones. Look at this table. It starts at 5, but the table that I want starts at negative 4. Let's go ahead and table set. Means table set. In blue, hit the second. Little up arrow lets me know I'm in second functionality. Here I have 5, but I want that to be negative 4. Remember, on this calculator, the negative's on the bottom. This is a subtraction sign. I know that the difference between each row will be 1, aka the delta. That's that little triangle. And in this case, I'm going to automatically calculate the independent variable. I'm all good here. Let's go back to table. Check this out. I know that at negative 4, this is supposed to be 32. At negative 3, it's supposed to be 21. At negative 2, it's 12. And I can just read it down, right? 5, 0, negative 3, negative 4. At 3, it looks like it's going to be negative 3 again. At 4, it's going to be 0. At 5, it looks like it's 5. Well, that's kind of cool. At 6, the thing is going to be 12. At 7, it's going to be 21. And at 8, it's going to be 32. Kind of nice because it's symmetric. Remember, in each one of these things, I can write it as an ordered pair. I'm not going to make you watch that whole thing. I'm going to do it, don't get me wrong, but I don't want to make you suffer. So here we go. Let's go ahead and write each one as an ordered pair, and then I'll fast forward. All right, I actually wrote each one as an ordered pair. The next step of this is actually to graph each of these ordered pairs on the axis, if I can find it. Notice this axis goes -4 to 8. -4 goes up to 32. There is no 32 on this graph, so I can't actually graph that. 21, same problem. -2 looks like I got -212 I can do. So here, if I hit -2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's a dot right there. I'm going to go ahead and graph all those dots. Fast forward while I'm doing it. I'll do the same thing for the red one. Recognize that I'm just fast forwarding this so you don't have to suffer as much as I am. Here we've graphed the parabola. Remember, real parabolas have curves. Let's do the line. Here's the line y equals 12. It's horizontal. There's no slope. The slope is 0. That's another way to say that. We go back to our description of the graphical technique. Check it out. We've just finished steps 1 and step 2. Step 3 of the graphical technique is to find the points of intersection between the graphs of the two functions from steps 1 and 2. Then, in step 4, we're going to write each point of intersection as an ordered pair, x, comma, y. Finally, we're going to set the variable in the equation equal to the value in the first coordinate. Here we go. Let's go ahead and finish those steps. Looks like the left point of intersection is going to be at -2, 12, and the right point of intersection is going to be at 6, 12. We could have seen this on our graph because the input -2 produces the output of 12 on both functions. Same thing, the input of 6 produces the output of 12 on both functions. Once we've specifically written the points of intersections as an ordered pair, we remember the solution to our equation is the variable equal to the value in the first coordinate. In this case, the value in the first coordinate is -2, so we said variable x equal -2. In this case, the variable is equal to 6, so we said variable x equals 6. We should normally check our work, except if we remember back to the work we did in the last video, these are the exact solutions. Let's check. Yep, here it is. This is the work that we had at the last video. X equal -2, boom, boom, boom. X equals 6, boom, boom, boom. We got our stuff together. Graphical technique works the same way as algebraic. Get the same answers, work in a different way. In the next lesson, we're going to do more factoring with exotic A coefficients. I can't wait to see you there. Right now, I'm going to go rest.